When an ionic bond is formed, one of the partners is going to lose electron and make a cation. The other partner is going to gain an electron to make an anion. We said losing electron takes energy, adding electron to another atom is going to release energy. So if I want to calculate the total amount of energy exchange, all I have to do is to add these together. And if there is energy factor needed or released in the process, I have to add those as well to calculate total energy involved. So I'm going to go to the next slide. You have seen this in Chem 2A. We said sodium is going to lose electron to make sodium ion. So obviously in this process, we have to use energy to remove electron from sodium. Chloride is going to gain electron to make Cl minus. In this process, energy is released. And we have to consider that in the formation. We usually look at, for energy, to make our life easier, we look at the gaseous state where these changes are happening. Once these are formed, the sodium ion, chloride anion in the gaseous state, then they have to be converted to solid. Obviously, when gas is converted to solid, it's going to release energy. So in addition to ionization energy and electron affinity energy, I have to calculate how much energy is needed to convert solid sodium metal to gaseous sodium metal. And how much energy is needed to break the bond between two chlorine atoms. As you might remember, the element chlorine is always in diatomic form. How much energy is released to break this bond? So we are going to break the process of formation of this solid from sodium metal and chlorine gas to several stages, then I can do the calculation. Let's go to the next slide. This process that we break down formation of a solid ionic compound from its component at gaseous state, we call this Born-Haber cycle. So this is the purpose. We want to calculate if you start with metallic sodium, which is the most stable form of sodium at room temperature, with gaseous chlorine, which is the most stable form of chlorine at room temperature, and you make table salt, solid table salt, what is the value of energy exchange in this process? Is reaction endothermic or exothermic? As you see, this one process is broken into 5 processes, 5 steps to make our life easier. So I'm going to start. Are we starting here with sodium metal? So I start with sodium metal. And I calculate, I look up the value of energy needed to convert sodium metal to gaseous sodium. That's energy of sublimation of sodium, going directly from solid to gas. I have a value for that in the tables. That's why I am starting with this form of transformation where I actually have data available. I'm reacting this with Cl2. I'm going to calculate what is the amount of energy to break down the bond between chlorine and chlorine. That's called energy of dissociation of chlorine-chlorine bond. How much energy is needed to break this bond? But remember, total amount of energy that I need for this process, dissociation energy of chlorine, is 244 kilojoule per mole. I need, in other words, it takes 244 kilojoule per mole for this reaction. But remember, look at this. This reaction is producing 2 chlorine. Why don't I divide this by 2? So I calculate how much energy is needed to make 1 mole of atomic chlorine, not 2 moles. Again, these are coming from table. You're not supposed to know this. You're not supposed to memorize this. Okay, now that I have got gaseous chlorine, gaseous sodium, now I have to go through the process of making sodium cation by removing 1 electron. That is energy of ionization. First ionization energy of sodium, 495.8 kilojoule per mole. So I also need to make Cl minus. I need to add 1 electron to 1 mole of chlorine atom, gaseous chlorine atom. This process is energy releasing. We already said it's electron affinity for chlorine. There is a table. Energy release when you're adding 1 mole of electron to 1 mole of gaseous chlorine is negative 340.6 kilojoule per mole. That's the amount of the energy which is released. That's why you have it blue. Red, absorbing energy on the left. Blues are releasing energy. So at this point, I already have Cl minus in the gaseous form, and I already have an Na plus in gaseous form. In the gaseous form. So obviously these two have opposite charges, they love each other, they make a bond, and that bond is called ionic bond. But we don't want gaseous NaCl, we want solid, S for solid, solid NaCl. Another word, when these two are made, they make a bond together and they solidify, they make a crystal structure, a cubic structure. So we can look up energy release when solid sodium chloride is formed from reaction of gaseous sodium ion and gaseous chloride ion, and that's called lattice energy. Again, coming from a table. So the total of these 5 processes is going to give me this value. Add all the negatives with all the positives. And this is what you get the result. So this reaction overall is releasing heat, negative delta H. means energy releasing reaction is exothermic. That means sodium chloride, solid, table salt, is more stable, has less energy than metallic sodium and chlorine gas. That's why these two react together to make sodium chloride. So this process, breaking down the whole reaction to a small step at a time, where we can use the information available to calculate overall process, is called Born-Haber Cycle. I hope this makes sense. Please make sure to come and see me during the office hours and lab time so we can do one-to-one interaction for you to understand these.